All right, now we're looking at our second part of the 5.3 video. We're on to frequency charts and histograms. Now these are all just going to be pictures that describe our distributions. So there are certain types of histograms or frequency charts that we can see. If most of our data points are in the middle, there's a little bit on this end, a little bit on this end, a little more in the middle here, a little more, but in the exact middle, that's where we find the most. It creates kind of this bell shape here. That's called a normal distribution then, or it's normally skewed. If it looks like there are, there's a pretty specific cutoff point right here on the lower end, but that there's a lot of extra little points here off on the right-hand side, kind of in the higher area, we would call it positively skewed. Normally, there shouldn't be all these extra points here. Over here, it just stops. And there leaves all these extra points over here in the positive direction, or the upper direction. So we call it positively skewed or skewed to the right. On the other hand, if there's kind of a cutoff, specifically on the right-hand side or in the higher area, but there's all these extra little ones kind of in the lower numbers, we would call it skewed to the left. You can see there's extra numbers on the left side, or it's negatively skewed. So these charts basically just kind of plot out numbers or frequencies of our data and then show, again, is this a normal distribution? Is it positively skewed or negatively skewed? For example, if we want to determine whether the data below appears positively skewed, negatively skewed, or normally distributed. Now, they took all of these data points, things like 100, 110, 90, 120, 80, numbers like this. They made what's called a frequency table. That just says here is our value, 80, 90, 100, 110, and 120, and wrote down the frequency, so how many times it happened. 80 happened twice. We can see it here and here. 90 happened 4 times. 1, 2, 3, and 4. So that would be our frequency table. Using that frequency table, then, we can make what's called a histogram. A histogram just says we're going to take these values, so like 80, 90, 100, 110, and 120, and then chart out how many times each one of them happened. So 80 happened twice, 90 happened 4 times, 100 happened 7 times, 110 happened 3 times, 120 happened 2 times. Since this histogram is roughly symmetric, it basically looks almost the exact same. This one is just one away from being the exact same as that one. We would call this normally distributed. You can notice that the one that has the most is in the exact middle. It's not a little to the left, it's not a little to the right, it is the exact middle, so this would be normally distributed. So, for example, if we wanted to create a histogram from the data below, given here, and describe our data as being skewed right or skewed left. So we would take this data, 27, 24, 29, and so on, and make our frequency table. 22 happens 4 times, 24 happens 5 times, 25 happens 4 times, 27 happens 3 times, and 29 happens 2 times. We've already got them counted out here. Now we would make our bars for this. I'm going to use red and say 22 happened 4 times. So there's going to be one of our bars for this histogram. 24 happened 5 times. So we're going to draw that one out. 25 happened 4 times. 27 only happened 3 times. And 29 only happened 2 times. Now, as we look at our highest value, it's definitely not right in the middle. It's a little bit further to the left, on the left end here. So there's extra values on the right side here. It almost looks exactly like this piece. There's kind of a distinct cutoff here with extra values on the right, just like this shape. We would call this one, oops, make sure I have my marker, skewed to the right. Again, this is what our histogram would look like. Extra values on the right, it is skewed to the right. Let's use this data set. They've already made the frequency table for us. It looks like they checked the shoe size of some people and wrote down how many times each one happened. So, size 4, we only got 1 student with that. So, we're going to take our, I'm going to do blue this time. Size 4 only happened once. Size 5 happened twice. Size 6 happened 4 times. Size 7 happened 8 times. 8 happened 5 times. 9 happened once, and 10 happened twice. Now this one, even though this one got a little bit smaller and 10 went up, again, it looks like our biggest value is right here in the middle. We can also see that 1, 2, and 4, that's going to be 7 values there. 5 right here, 1 and 2, that's 8 values on this side. So there's almost the exact same amount on this side as there is on this side of our tallest middle piece. That means this one is going to be pretty much symmetrical. It almost makes, oops, I want my marker. It almost makes that perfect bell shape that we were looking at before, just a little bit off. So this one we would say is normal. It's not going to be skewed to the left or to the right. Let's look next at measures of variation. Now, measures of variation, or spread, measure how spread out or scattered your data is. The easiest measure of variation is to use the range, the difference between the maximum and minimum of your data set. Now, variance and standard deviation are also measures of variation that kind of indicate or tell us how much the data values change or vary from the mean. Again, it basically just shows us how far each one of them, or the average of how far each one of them is from our average or our mean value. So, looking at an example here, if we want to find our variance and standard deviation of the data set 10, 9, 6, 9, 18, 4, 8, and 20. Well, first we need to find our mean, and they use this little value x with a bar over the top. That's to show average or mean. If you have an x with a bar, that means mean or average. Now again, to do that, we'd have to add up all of our values and divide by the number that there are. There are 8 of them. So 10 plus 9 plus 6 plus 9 plus 18 plus 4 plus 8 plus 20, and then divided by 8, we would end up with 10.5. So this is going to be our mean value. This is our average of all of these numbers. Step 2, to find the variance. We would take each of our numbers, 10, 9, 6, 9, 18, 4, and so on, and we would subtract this mean. This would show how far they are away from it. Once we have that subtracted value, some of them will be negative and some of them will be positive. What can we do to make sure they're all giving us a good positive number? Well, we will square them, so multiply them by themselves. When we do this then, and we add them all up and divide by the number of terms they are, this would be called the variance. It is signified by this Greek letter sigma. Sigma looks like this, and we put the squared because we had to square them to find the variance. So we take our first term, subtract the mean, and square it. Second term, subtract the mean, square it. All the way down to our last term, subtract the mean, and square it. This would look like, given our data set, 10 minus 10.5, and then square that value. 9 minus 10.5, and then square that value. Next would be 6 minus 10.5, square that value. And 9 minus 10.5, square that value. We would add up all of those on top, and then divide by 8. This would give us 27.5. So we would say that the variance is 27.5. Now to find the standard deviation, we would take the square root of this 27.5. We don't want to have a squared, so the sigma, just plain sigma, is our standard deviation. That would be about 5.2. That means that all of these values, 10, 9, 6, 9, 18, 4, 8, and 20, on average, they are 5.2 values away from 10.5, which kind of makes sense. It looks like our lowest value, 4, is pretty far away from 10.5, but so is 20, our highest value. We also have a lot of numbers, 10, a couple 9s, 8, that are really, really close to it. So on average, we're not going to be too terribly far away from this 10.5. Now we're going to look at using technology to figure this out for us. Now first off, I'm going to show you how to use it with the TI-84 Plus calculator. I will also show you it on the next slide, how to do it with a Casio FX9750 calculator. So finding the standard deviation. First you need to enter the data. So you go into your lists, find your lists, and just enter all of the data. So the 10, the 9, the 6, the 9, 18, 4, and so on, all of them to make sure that they are put into a list. Step 2, you would go to the menus and find Stat. From Stats, you would Calculate, or CALK. We want 1-var stats, just one variable stats. We're only looking at one variable here. All of these just have one value with them. Then we would hit Enter. Second, L1, that tells us we're using list 1 as our calculated statistics, and then hit Enter. This will calculate everything for you. X bar, which remember is the average, is 10.5, just like what we calculated up here. This one, the uppercase sigma x, means what happens when you add all of these together. So 10, 9, 6, 9, 18, 4, 8, and 20, if we add everything together, it would come out to 8.4. If we were to square each of our values first and then add them all together, that's what this one would be telling us. These ones are not going to be as important as x bar is, and as this lowercase sigma x. That will give us our standard deviation. Here is our mean, our average. Here is our standard deviation. Note, variance is going to be the square of the standard deviation. If we take this number, 5.244 and so on, and square it or multiply it by itself, that would be the variance. Before we go on to looking at the variance and standard deviation of these ones, I want to look at how to find it on the Casio. From your Casio calculator, hit Menu from the regular screen. You will see a few different icons. Move it over and make sure that the STAT, or the statistics, the stat one, is highlighted. Okay, click on that, click Enter. You will find your list. It'll look something like, something like this screen, where you can just input a number, hit Enter. It'll give you the next number to put in, hit Enter. The next number, hit Enter, and so on. After you've input your list, hit F2 on your calculator. On the screen, it should say CALK, or calculate. From there, you're going to hit F1. That is, again, the one variable statistics that we're looking for. After you hit F1, it should give you a list that looks very similar to this screen. You'll see the X bar, the uppercase sigma x, the uppercase sigma x squared, and so on. Again, this is just what each one of those means. X bar is the mean of all of your data. The uppercase sigma x is the sum of all of your data. Just take everything and add it up together. If you square each of your datas, or your data values, and then add them all together, that would be this, the sigma x squared. Now, the population standard deviation is what we're looking for. It has the lowercase sigma with an x. This is just going to be the overall standard deviation of all of our data, looking at the ones that we were given. The sample standard deviation just has to do with the numbers we were looking at. So that's not going to help us as much. We don't want that. We want the overall population standard deviation. So always use this sigma x. The n tells you, of course, how many data items there were, the number of things you plugged in. Min x is the minimum value. Q1 is your first quartile. MED is your median. Q3 is your third quarter. MAX is the maximum. These 5 right here can be used to help you make a box and whisker plot. So you can always use the calculator to help you find these pieces before you make a box and whisker plot. MOD is the mode. So if it says MOD and then gives you one number and says MOD again with another number, that means there's 2 modes. So it might say MOD 2 and MOD 5. Both 2 and 5 are the modes for that set of data. MOD semicolon N means the number of data modes there are. So in that case, if it said 2 and 5, this would come up to be 2. It's telling us there are 2 numbers that are the modes for this. And then MODF is the data mode frequency. So if 2 and 5 were both the modes, and they both happened 4 times, this would say 4. 4 is the number of times that our mode happened. So let's go back down to this example. Using your calculator, type in this list: 400, 300, 325, 275, 425, 375, and 350. I'll give you a second to pause the video right now. Try that on your calculator. Plug these values in and see if you can run the stats to find your standard deviation and everything for you. Now that you've tried it on your own, we're going to double check and see if all your answers are correct. When you do it on your calculator, notice that you didn't actually have any of these that said the variance, but we did have the standard deviation. We could find the standard deviation of this set to be 50. To find the variance then, we just take 50 and square it. 50 times 50 is 2,500. So here's our standard deviation. Suppose I can draw in a little extra curl here. So it's a sigma. Sigma of x is 50. The variance overall is 2,500. To find the range of our data set, it's the max minus the min. So 425 was our highest, 275 was our lowest. 425 minus 275 is 150. That would be our range. So again, you can find this values, the max, the min, and the standard deviation right on your calculator. Try it again. Put in these values into your calculator. Have your calculator find the standard deviation for you. Square it to find the variance. Use the information again to find the max and the min. Subtract those to find your range. Do that with these values: 4.3, 6.4, 2.9, 3.1, 8.7, 2.8, 3.6, 1.9, and 7.2. Now that you've had a second to try that out on your own, let's double check and see if we got the same answers. Oops, I'm going to write in the extra curl for the sigma. The standard deviation should be 2.199, around there. If you were to square that, 2.199, your variance would come out to around 4.836. So this should be your standard deviation and your variance. Your range, remember, is the max minus the min. So 8.7 is our highest value, 1.9 is our lowest value. 8.7 minus 1.9 is 6.8. So that would be our range. This was, again, how to find everything on the Casio or on your TI-83 or 84 calculator. This is what each of those symbols means or is telling us. Let's try one last example here. Find the variance, standard deviation, and the range from the list of prices given in the table. Round to the nearest cent. So here we have 10 brands of breakfast cereals and their prices. We can input each one of these into the calculator and run our one variable statistics test to find each of these pieces. When we do that, we would find the standard deviation to be 0.3257. Now if we wanted it rounded to the nearest cent, this would become 0.33. So all of these are going to be around 33 cents away from each of those pieces, or from our middle piece, our median, our average, our mean. The variance then would be this number squared. So we would get 0.1061. Again, if we rounded this to the nearest cent, it would come out to 0.11, or 11 cents is our variance. The range then, we're going to take our highest value, subtract our lowest value. Our highest is $3.39, our lowest is $2.29, so our range is going to be $1.10. All of these values are within $1.10 of each other. Now it asks how many prices are within one standard deviation of the mean. Now when I calculated this, I used that full standard deviation out to 4 places. So to do this, we would have to take our mean. We can find our mean on the calculator again. Oops, and our mean would actually have a bar over the top. This is our average value, $2.96. Now, to find all of them that are within one standard deviation of each other, we would add on the standard deviation to find that kind of the highest value that would work, and then we would subtract the standard deviation to find the lowest value that would work. So $2.63 rounded is going to be our lowest value. $2.28 rounded is going to be our highest value. Which ones would work? This one is too low. This one is too high. This one is right in between. That works. This one is in between. This works. This one is in between, and it works. So does this one. $2.79. This works. This one will work. This one is going to be too low, and this one is a little too high. It's right above that 28 cents. So we would count up then which ones actually do work. So we would say 1, 2, 3, 4, 5, 6 of them will actually work. 6 are within our range. What percent of the prices are within one standard deviation of the mean? Well, 6 out of 10 work, so we would say 60% actually work. Let's look now at how changing data affects the summary statistics. If this is our first data set, 1, 5, 6, 9, 13, 20, 22, 33, 55, 56, and 100, we need to find the mean, median, mode, range, interquartile range, and the standard deviation. Plugging these values into the calculator and running our statistics will help us find each of these. The mean, median, and mode will all be found right on the calculator. They'll let us know that the X bar, the mean, is 30. The median is going to be 17.5. Now on your calculator, it'll tell you that every single number is the mode. This would tell us that there is no mode. All of these happen only once, so we can just simply say no mode. The range, again, it would give you the highest is 100, the lowest is 1, subtract those, and we would get 99. It wouldn't tell you the exact interquartile range, but it would tell you that we take our upper quartile minus our lower quartile, and we would get 49. It would also let us find the standard deviation. That's the sigma, one that looks like this. Sigma would come out to 30.076. So using your calculator, just typing these in, we would find each of these no problem. Now, if we were to add 10 to every number in the data set and then recalculate what we found, how would each of these change? So this would now be 11, 15, 16, 19, 23, 32, 43, 50, or 66, 65, sorry, 66, and 110. Those values would be plugged into your calculator, and we would get something that looks like this. Our mean would now be 40. Our median would now be 27.5. There would still be no mode. Our range would still be 99. Our interquartile range would still be 49. And our standard deviation would still be 30.076. This means that nothing else changed except for the mean and the median, which both went up 10. Which makes sense because we went up 10 with every single number there was. So the things that would change would be our mean and our median. Now let's say we're going to multiply every number in the data set by 3 and recalculate what we found. What changed and how did it change? Well, as we recalculate then, we would get our mean is 90, our median is 52.5. There is still no mode. Our range is going to be 297. Our interquartile range is now 147. Our standard deviation then is going to be 90.229. Now what changed? Everything. Every single piece was multiplied by 3. Now why did it change that all of these were multiplied by 3 and only these two went up by 10? Well, if everything goes up by 10 together, not a whole lot changes. Just our average and the middle ones. The range, everything is still in the same area. Everything is going to be the same amount away from our middle piece. All of the modes, everything else should stay the same as long as everything goes up by the same amount. When you're multiplying by 3, not everything goes up by the same amount. This number went up by 2. 1 times 3 is 3, so it means 1 only went up 2 amounts. 100 times 3, though, is 300, which means this one went up 200 points. So this one went up a lot more than this one. That's why it throws every number off. So when you multiply it, all of them will multiply by that amount. When you add, really it's only the mean and the median that will go up by that amount. Unless there is a mode, in which case the mode would go up by that amount as well. And that'll cover it for 5.3.